Okay, so today we're looking at the term 2 cycle test of May 2022. Right. So let's go into the first sum here. The question says solve for x in each equation below. So firstly, one of two ways I can do this. You can either go from the outside in or the inside out. Inside out is going to be the more easier way to easy approach. So it's going to be 3 into x minus 4x plus 2x minus 6, okay, equals x. Now one of two ways, two things I can do here. It's either I add the like terms inside or I multiply the negative in. Yes? 3? 2 times negative 3 is negative 6. Are you talking about this negative 6? You must remember that 2 times x is 2x and 2 times negative 3 is negative 6. So what is the issue there? It's fine. Okay, nice. So it's going to be 3 open brackets x minus 4x minus 2x plus 6 equals x. Again, one of two things I can do here. Either you add your like terms or multiply the 3 in. We're going to multiply the 3 in there. So 3x minus 12x minus 6x plus 18 equals x. X is one side, numbers are the other side. So it's 3x minus 12x minus 6x minus x equal to negative 18. 3x minus 12 is negative 9x minus 6x is negative 15x minus 16x is equal to negative 18. Divide by negative 16 both sides. So x equal to negative divided by negative is positive. 2 goes into 18, 9 over 8 times. Right, that's more like it. Not so. Alright, let's carry on with our lives. In number 1.2, question 1.2. Solve for x. This is your algebraic equation. Okay? So what's your LCM here? What's your LCM? 4. Your LCM is 4. So naturally that's over 1. So 2 must be multiplied by what to get 4? By 2. So it's x times 2 minus. The 4 must be multiplied by what? 1. So it's x minus 3 equals. 1 must be multiplied by what? 4. So it's 4 times 7. So we get rid of the brackets. 2 times x? 2x. Negative 1 times x? Negative x. Negative 1 times negative 3? Plus 3. 4 times 7? X is one side, numbers are the other side. So we take that over. So 2x minus x is equal to 28 minus 3. 2x minus x is x, 28 minus 3? 25. You can only drop the denominator in an equation. Okay. Let's carry on. The next question. A mother is 3 times as old as a daughter. So you got mother-daughter situation here. Who's younger? The daughter. So you make that, let the daughter be x. Okay. Let D be x. So the mother currently would be 3 times as old as the daughter. So the mother currently is 3x. That's present. Okay. 6 years ago. 6 years ago. 6 years ago. The mother was 3x minus 6 and the daughter x minus 6. The mother's age 3 years ago, the mother's age was 6 times that of her daughter. So you got mother, you multiply the daughter by 6, you get, when multiply the daughter's age by 6 you get the mother's age. So if it says here 6 years ago, the mother's age was 6 times that of the daughter. How old are they now? So 6 years ago, no? So the mother was 3x minus 6, the daughter was x minus 6. Get rid of the bracket there. So it's 6x minus 36 is 3x minus 6. So it becomes 3x minus 6x, negative 36 plus 6. It's negative 30 and negative 3x. So therefore x is equal to 10. They want to know how old are they now. So the daughter is 10 years old and the mother is 3 times 10, which is 30 years. Okay. You all okay with that? Yes? Alright. Miss Dixon is busy writing the marks down. In the next question, in question 2, we are told that in the diagram below, ST is parallel. So we're going to put here, ST is parallel. So if ST is parallel to RP, calculate with the reason the value of A, B, C, and D. So we're looking at A. You see here? I'm going to calculate A. Going to the angles. Can you see that, people? So also you could have applied, you could have worked out B first if you want. Okay? They didn't say in order. But we are going to go in order. So A plus 154 is equal to 180. Why? Go interior angles with TS being parallel to PR. Okay, are you all okay with that? Right. So then A is equal to 180 minus 54, 154. It's going to give you 26 degrees. Is that correct? So A is 26 degrees. We're looking at B. B is equal to 48. Why? Corresponding angles. So B is equal to 48 degrees. Corresponding angles. TS being parallel to PR. Is 48. C. Can you see as alternate angles? Okay? So C is equal to 26 degrees. So alternate angles with T is being parallel to PR. To calculate D is one of 3. Angles of a straight, angles of a triangle, angles in a straight line, whatever. Going T you could have used D as well. So D plus 26 plus 48 is equal to 180. It's angles in a straight line. So D is equal to 180 minus 60, 74. So it's going to be 160 degrees. Check if that's correct. Right. Any confusion here? Right, let's carry on. Yes? Sorry? Okay. Yes? Yes? Some of the triangles will also get you the full marking. But all in the diagram, R is T. R is T. Is a triangle. QS is a straight line. Calculate with the reason the value of X. So exterior angle is equal to sum of the two interior opposite. Not so. So it's 140 degrees equal to 3x minus 10 plus 2x plus 30. That is exterior angle of triangle and it's triangle TRS. So that's going to give you 140 is equal to 5x plus 20. X is one side, numbers the other side, so 140 minus 20 is equal to 5x. 140 minus 20, 120 divided by 5. 5 goes into there twice, carry 2, 24 degrees. You all okay with that? Okay. Just go check if Miss is done with the papers, please. Then it says, hence calculate the size of TRS. Hence calculate the size of TRS. So you're going to look at TRS. So in other words, it's this angle they want you to work out. Not so? So TRS is equal to 3x, which is 24, minus 10. 3 times 24 is 72. 72 minus 10? 62. Okay. Any confusion there? Yes? Is this one wrong? Or is it 35? No, I wrote 2x plus 30. It's 2x plus 35. So all of this is wrong. Whoops. You see, my mistake was I wrote 30 here. Okay, but no problem. We'll just redo it, okay? So that there is wrong. Will that be wrong? Okay. So it should be plus 35. Yes. Okay? So that's going to give you 5x plus 25 equals 140. Take it over. It's 140 minus 25 is 5x. 35. But negative 10 plus 35 is 25. So that's going to give you 115. No? Yes. Right. Divide by 5. So x equal to 2, carry 1, 23 degrees. Right. Now, TRS is 23. 3 times 23 is 69 minus 10 is 59. Okay. Don't make the same mistake I'm doing, eh? By writing the wrong stuff down from the question paper. People at least have thought most of you are going to get this right. But then again, I told you go learn this stuff, you people must not learn this stuff. At least one pair of opposite sides are parallel. At least one. So it can be 2 or 1. So that at least one pair of opposite sides parallel. Rectangle, square, rhombus, trapezium, not a kite. Where does it say you can only take one? Use the table in the answer book provided to take the properties which apply to each quadrilateral.
So I only take one. So you need to
Sorry?
At least one.
Right, adjacent sides are equal. So the adjacent sides in the rectangle is not equal. In the square, yes. In a rhombus, yes. A kite, yes. Not so. Then we are told the angles bisect each other. Rectangle, square, rhombus. Not a kite. Because in a kite, one diagonal bisects the other. So it can't be a kite. Yes. But listen, the mark is given down, not across. So you got everything in a rectangle right, you get the one mark. You understand? Right. The angles meet at 90 degrees. Square. Rhombus. Kite. The angles are equal in length. Only 2 of those. Rectangle, square. Okay. Let me just see. Right, next. People, settle down, please, man. Please. (3.2). The question says, the diagram below shows a rhombus. So we know the rhombus, there are 6 properties. I'm not going to go through them all now. E and F are points on AB and AC respectively such that E, G, C, F is a parallelogram. All these 4 properties of a parallelogram is evident there. The question says, G is a point on BC. AB, BC, sorry. BC. Sorry, G is a point on BC. AB is equal to AB is equal to AC. So this length here is equal to that length here, which is resulting in that angle being equal to that angle. Angles opposite equal sides. Okay? Then we are told the angle D is 60 and EGC is 120. The first question says, determine with reason the size of angle B. Now that's 60. Not so? Why? Because this is a rhombus. Not so? So angle B is equal to 60 degrees. The reason is that opposite or 2 pairs of opposite angles equal in rhombus. Okay, you can't just write properties of a rhombus. Right. Now the question is to calculate BEG. BEG. Now you see this exterior angle is known here. Exterior angle is equal to sum of 2 interior opposites. Okay? So BEG plus 60 degrees equals 120. Let me just write it here. So BEG plus 60 degrees equals 120. Why? Exterior angle of a triangle. And that is triangle EBG. So BEG is equal to 120 minus 60, which is 60 degrees. Okay. You all agree with that? Number 3. 6.2.3 or 3.2.3. Is going to pause the video at this point. Okay, so 3.2.3 it says you must calculate BCA. So angle B, C, A, this angle here. Now, we know that these lines are parallel. So what can we apply here? The co-interior angles. Not so? We apply the co-interior angles here. Or, we know that this length was given equal to that length. Not so? So that angle is equal to that angle. Anyway. You guys understand? However, if you're going to go with that lines that are parallel, then we must first state that EG is parallel to FCY, because this is a parallelogram. Okay, and then we can use that. But we are told that this length is equal to that length. So we're simply saying that ACB is equal to 60 degrees. Why? Angles opposite equal sides. So there you go, 60 degrees. The next question, that is 3, let's look at 4. AFE. So AFE, this angle here. So you see that line is parallel to that line. Not so? So now we can say that that's going to be 60 degrees because of corresponding angles. Can you see that F that's formed there? F is being formed like this. Those lines are almost parallel. So its corresponding angle is going to be equal there. Okay? 60. So we first must say that EF is parallel to BC. Why? Because two pairs of opposite sides parallel in parallelogram. Remember that EFCG was given as a parallelogram. Okay? So therefore, AFE is equal to 60 degrees. Why? The corresponding angles are equal, with EF being parallel to BC or GC. Okay. It's number 4. 1, 2, 3, 4. See at 5? No. Let's go to the next question. 3.3. State with reason the size of C2. We are given that ABCD is a kite. So there's a kite. We know all the properties that is associated with a kite is evident here now. Okay? There's a lot of questions here, no, for this one. Okay, just leave it. So ABCD is a kite. So we know that this length is equal to that length. That length is equal to there. That's perpendicular. This angle is equal to that angle. That angle is equal to that angle. And there that MB is equal to MD that was given to us. Okay. So they tell us a kite. So all 5 of those properties comes to mind. Okay. So the question says, state with reason the size of C2. Angle C2. I already indicated that. So C2 is equal to 30 degrees. Why? One diagonal bisect the vertex angles. So one diagonal is bisecting the vertex angle. Okay. So that's the reason there. So now we put 30 degrees on the diagram. Okay. My girl, just stop it please, man, if you don't mind. Sit properly. Let's look at number 2. Number 2 says, write down the length of BM. So if you're looking at BM, we are also told that DB, this whole length here, DB, the length is 10 centimeters, okay? So what is the length of BM? Who's half of that? So you say BM is equal to 5. Not so. Why is it 5? Because it's given that BM is equal to MD. That was given to us. Sorry? No, this length is 10. And if that is equal to that, if this length here is equal to that length here, I must divide that 10 by 2. Then I get 5 and 5. Okay. Then for number 3 it says, calculate with reason the length of AM. Calculate with reason the length of AM. So that's the length you must work out. AM. Not so? So how do you think you're going to calculate AM? by using Pythagoras. Now, even for what's the theorem of Pythagoras? Who can state the theorem of Pythagoras in words? In any right angle triangle. If you ask you an exam for 3 marks, state the reason of the theorem of Pythagoras. You state that in a right angle triangle. Write this down. Looks like nobody knows what I'm talking about. In any right angle triangle. In any right angle triangle, the hypotenuse squared, that is the O is the opposite. The hypotenuse squared is equal to the sum of the other 2 sides squared. Normally that question comes in for 3 marks, okay? In any right angle triangle, the hypotenuse squared is equal to the sum of your other 2 sides squared. Okay, know that, alright? So, you want to apply Pythagoras to calculate AM. Not so. But what was the condition there? The first condition given. It has to be a right angle triangle. Not so. But is this not a right angle here? Yes. And why is that a right angle, Jessica? What are you busy with? You're busy on your phone. That is the reason why you got what you got, my dear. You don't take note of what's happening here. Right, that is 90, not so. So we need to say first that AMB is equal to 90 degrees. Why? Because your diagonals are perpendicular in a cut. Diagonals perpendicular in a cut.
So isn't the diagonals
Same. You have written that, I give you a mark for it. Now it's a right angle triangle. Now I can apply Pythagoras. Can you see that, people? You can't apply Pythagoras in any triangle. It has to be a right angle triangle. So now we say hypotenuse squared, which is AB squared, is equal to BM squared plus AM squared. Reason? Pythagoras with AMB equals 90 degrees. Okay? So you get 13 squared equals 5 squared plus AM squared. That is going to give you 169. That is 25. So it's minus 25 is AM squared. So AM squared is equal to 144. The square root thereof is 12. Okay, so it's since those lengths in centimeters, that should be in centimeters as well. Okay, and there they gave you 4 marks for that. Okay. Then we carried on to question 4. In question 4, we are told that in the diagram below, ABCD is a square. Now 7 properties comes to mind now, okay, of a square. Then we are told that prove that, I'm going to put here 4.1. We must prove that triangle PBR. So we always start by saying in triangle PBR and triangle RDP. So if you go PBR and triangle RDP. We are proving that those two triangles are congruent. So where do we start? You see PR is in both triangles. So PR is a common side. Right. What else can we say? P2 is equal to R2. Can you see that, people? Alternate angles there. So P2 is equal to R2. Why? Alternate angles. With PB being parallel to RT. One more. Sorry? We either need another angle, or if we're going to use a side, it must be PB. PB we can't, no? So the other angle here is going to be P3 and R1. Can you see them? These are alternate angles. Okay, can you see that, people? So we're saying that P3 is equal to R1. The reason there is alternate angles with PD being parallel to BR. So therefore, triangle PBR is congruent to triangle RDP. Why? Angle, angle, side. That's your case for congruency. We use two angles and a side. Yes? Who's sleeping? Wake up. Then the next question in 4.2. You alright, girlfriend? Who's Peter? Yes. Now what name were you saying? You're talking in your sleep. Watch it. Might have given your secrets away. Okay. People 4.2. Come. 4.2 they ask you to prove that triangle ABD ABP, this triangle, is congruent to triangle CDR. CDR. Okay, so this is a square, so angle A has to be equal to angle C. Why? All angles are equal in the square, which is equal to 90 degrees. All vertices are 90 degrees. That's one. We need another one. A. We just said that A is equal to C. Another one. A. B is equal to DC. Why? Both sides are equal in the square. So I need one more. Is an easier way. R? How is R common? No. You should tell me R is not common. Nice. One more, people. You see, we have proven that these two triangles are congruent, not so? Which means to say that this length here is equal to that length. Not O. It's PB is equal to RD. Can you see that, people? So how do we start? We say in triangle ABP and triangle CDR. What did we say? We said angle A is equal to angle C, which is equal to 90. Why? All vertex or vertices or all vertex angles 90 degrees in a square. I know that's behind the calculator, okay? I think I can take it away. So then we said that AB is equal to DC. Why? All sides equal in a square. One more, the other one was PB is equal to DR. Why? Because triangle PBR is congruent to triangle RDP. We have proven this here now. So on this account, those lengths are equal. Okay. Now we conclude, therefore, triangle ABP is congruent to triangle CDR. And on what account of congruency is that? Nope. We use 90 degrees. And the? What is opposite of 90 degrees? The hypotenuse. So it's RHS. This is that case of RHS. Okay. The right hand hypotenuse side. Alright. And there we've done it. It was 8 marks for that question. Then you had a bonus question. Okay, in the bonus question we are told that in the diagram VT is equal to VW, which means to say that that angle there is equal to this angle. Not so. Then we are told that WTU, this angle here is 3x plus 15, whilst TUW is equal to 2x minus 30. Calculate the value of x. Okay. So, I need to set up an equation in order to solve it. Yes, Michael? Yo, you know, my heart light lit up. I thought you were going to ask me something about maths. Go to the body now. We said break now. Okay. So, we need to set up an equation here. Okay. However, these lines are parallel. So, I can set up the fact that this angle here, that angle adds up to 180. Why? Going 380. However, I am shorting angle VTW. Can you see that, people? But we know that VTW is equal to angle VWT. Why are these angles equal? Because it's angles opposite equal sides. Okay? So, VTW, this angle, plus 90 plus VWT, it's the same as VTW, equals 180. Just hang on. The reason? Sum of triangles. And it's triangle VTW. Take it over, becomes 90 divided by 2. 45 degrees. So VTW is 45 degrees. So what do we say now? We say 45 degrees plus 3x plus 15 plus 2x minus 30 equals 180. Why? It's co-interior with TV is parallel to UW. That gives me 5x is equal to 180. That's 45. 60 minus 30 is 30. It's 150 divided by 5x works out to be 30 degrees. Okay. Is there any problem with the way that your paper was marked? No. Okay, collect this to the files. Enjoy the rest of your day, people. Good afternoon, class. What happened? Huh? Never to be done again, huh? To be seen again.